In this second lesson, we're going to look at what makes the difference of two squares, how do you recognise it, and then we're going to look at some more difficult difference of two squares factorising questions where you have to do two separate steps. So let's look at this category sort first of all. We basically have to recognise which one of these at the bottom are difference of two squares and which aren't. So let's pick the first one. To recognise the difference of two squares, you need to subtract in the middle, firstly. You also need square values at the start and square values at the end. Now 16 is a square number because 4 4s make 16. However, 3 is not. The only way to multiply to make 3 is 3 times 1, so that's not a difference of two squares. The 1 plus the x squared, straight away, you should be looking at it thinking that's not difference of two squares because there's a plus there, so that's not either. This one here, we've got subtract in the middle, so that's a good start. We've got x squared and a y squared, that's good as well. 49 is a square number because 7 7s make 49, and 16 is also a square number, 4 4s make 16, so that would be fine. X squared plus, straight away we should be saying no because there's a plus in the middle. This one we've got a subtract in the middle, we've got a square at the start and a b squared at the end, that is. We've got a subtract in the middle here, but 8 is not a square number. You can make 8 with 2 times 4 or 1 times 8, but you can't make it with 4 times 4. That would be 4 add 4, so that's not a difference of two squares. 100 subtract 4m squared, so we've got the takeaway in the middle. We've got an m squared. 4 is a square number, 2 times 2 makes 4. And 100 is a square number because 10 times 10 makes 100, so that is the difference of two squares. X squared subtract 64, so we've got a takeaway, we've got an x squared, and 8 eighths makes 64. That's a square number, so that's good. Okay, so there we have 12x squared subtract 9y squared. So the subtract's there, the y squared is there, so is the x squared, that's all good. The 9 can be made by 3 times 3, which is good, but the 12 is not a square number. You can do 2 times 6, or 3 times 4, or 12 times 1, but you can't do 6 times 6. That would be 6 add 6. 6 sixes are 36. So that's not a difference of two squares. And finally, we've got a subtract in the middle. 1 times 1 makes 1, which is good, and p times p makes p squared, so that is the difference of two squares. So that would be a category sort. All these ones here are difference of two squares, all these ones here are not. So these ones would factorise into double brackets, and these ones would not. Okay, let's look at more difficult difference of two square questions. If you look at this example here, first, we've got a subtract in the middle. We've got an x squared, but 5 is not a square number, and neither is 45. But let's see if we can do something first to make this into a difference of two squares question. Looking at it, we should be able to recognise that 5 is a common factor to both parts here. So you could take 5 out, inside a single bracket. So if we take 5 out, then you end up with x squared subtract 9, because 5 times x squared is 5x squared, and 5 times negative 9 is negative 45. Now in this bracket is the difference of two squares. We've got a takeaway, 3 times 3 makes 9, and x times x makes x squared. So we can factorise that down, leave the 5 at the front, the multiple, and sort the brackets out into x minus 3, x plus 3. And that's how to factorise a slightly harder difference of two squares question where there's two steps. So let's look at some examples like that. Okay. So here we have 2x squared subtract 8. I've given you a wee hint on the first one. Take out 2 as a common factor first, so in the brackets we're going to have x squared. And then 2 times what makes it 8? Well, that'd be 4. You leave the 2 at the front and you factorise the x squared minus 4 just as a normal difference of two squares. That's going to be an x and an x, a 2, and a 2, and make sure you've got a plus and a minus. It doesn't matter which way around you have the plus and the minus. In the second example here, we have to find a common factor first to both parts. That will be 3. So 3 into 3m squared, you would multiply by m squared to make that. And 3 times what makes 48? Well, that would be 16. Again, leave the 3 at the front. We now have m squared subtract 16, which is the difference of two squares. M and m, 4 and 4 make the 16, and a plus and a minus, whichever way around you want. Okay, the last one in the top here, look for a common factor, which is 7. 7 times s squared will give you your first part, and 7 times 9t squared will give you your second part here. So again, leave the 7 at the front to multiple. S is at the start to make your s squared. We need a 3t at the back here. 3t times 3t will make your 9t squared, and then a plus and a minus, whichever way around you want. Okay, and finally these last harder ones, we've got x cubed minus 16x. Now there's no number that can come out of both parts because there's no number in front of the x cubed, but x can be taken out as a common factor here. So x times x squared will make your x cubed, and minus 16 will make your minus 16x. So leave the x at the front, the multiplier, and we'll need x's at the start to make your x squared, 4's at the end to make your 16, and a plus and a minus in any order you like. Finally here, we've got y to the power 4 take away 1. We need y squared times y squared will give you your y to the power 4. 1 times 1 will make your 1 at the end, and a positive and a minus. So that's the difference of two squares there. Now looking at this first bracket here, we've got y squared subtract 1. That is also a difference of two squares. The second one is not because there's a plus there. But the first bracket will split into these first two here. So y times y makes your y squared. 1 times 1 makes your 1 here, and a plus and a minus. And then this is your second bracket. This has just been rewritten down here.